Cool. Let me quickly introduce myself. I'm from Groq, as already mentioned. I'm a computer engineer, so I'm coming more in from like a hardware perspective in my conversation here. The nice thing is that Groq basically also owns the whole stack. So we own everything from the actual chip building up to giving API access to our cloud. And quick question, show of hands, who's already building with Groq? And we heard already one, so that's great. Cool, that's not a lot yet, and that's good because we basically have this console.groq.com that everyone can visit. Everyone can basically get their API key. You can start playing with it, and how does it look like? Basically, if you log into it, you will see the following window. You can choose out of a scalar of models that we support. You can automatically query this through with your API keys. You can actually also use it as a text-based system here. That's all up to the creativity of the apps that we want to build with it, right? And in terms of model support, this is the list of models that currently are supported, and that probably says a lot more to you guys than it does to me, but that's good. What I quickly wanted to show is two things that we can then build with this access to the Groq platform. First thing is going to be ScribeWizard, which is amazing because I think it overlaps exactly with the last presentation we saw. And the second thing is StockBot, which basically helps to find information about the stock market. So to jump into it, both apps that are developed were from people that work at Groq, but they are both open sourced. You can find the code and everything on GitHub. And it depends if you need an API key, you deliver your own API key for the Groq console. So if we look at ScribeWizard, what does ScribeWizard do? It basically creates structured notes from audio, which is more or less the same, and we support YouTube links. Unfortunately, as probably some people here know, that if you build with YouTube, you often get flagged as a bot, and at that point, you cannot get access to it anymore. So we also have that problem. Nice thing is we also support you to basically just drop audio in, and we have some example audio here ready. So I can just download that example audio, already had downloaded, drop it in, it waits for it to upload, and then I basically can just hit generate notes, and it will query, first of all, Whisper, and Whisper is used to then basically go from speech to text. So we will first do the speech to text generation, and then we use Llama 7 billion at the moment to actually do the summarization and key takeaway points. As you saw, it already happened in the background, so this thing ran currently at 1,200 tokens per second. That was the Llama 3 billion. Sorry, I made a mistake there. And it basically transcribed with Whisper, and then it did the whole summary for us. So we can start working on those long to-watch queues that we have in YouTube. This is all open, so feel free to play with it, look at the GitHub, and do inspiration of it. I'm more here to show that we can build all of this stuff and to inspire people building even better features on top of our cloud. So that was ScribeWizard. Then the other one basically is StockBot, and that's basically an app to query about stock information. It's built with a combination of LLMs, but LLMs, as we all know, don't have like the latest information. So we take the latest information from other places, put it all together, and then we create something called StockBot, which we can see here. And for example, we can ask for some recent events about Amazon. And at that point, it will give me the relevant news articles, and it can give us a short summary to us in turn. We can also ask it things like, what is the stock price of Amazon? And it will give us a nice overview of the current stock price of Amazon, and it's not doing all too great, so to say. So I would like to end this presentation with the fact that this is definitely not financial advice, as I think I should always put in here. And if there's any questions, please feel free to reach out, and any questions on like the hardware architecture and everything, I'm very excited to talk about that over some pizza. So it's all good.
I was curious about Groq. How much of the speed up of the models that you host is due to the hardware difference or versus the software optimization?
So it's an interesting question because basically the hardware at Groq is software driven. So we do model basically our hardware in a way that it feeds well to our software stack. So it's very going hand in hand. All the speed up, of course, comes from the fact that we can do our calculations different. We do have different hardware and it's a different architecture. So a lot of the speed ups actually come from decisions made in that hardware stack. And one of the major decisions, if we go really technical there, is the fact that we don't utilize something like HBM or DRAM, and we actually can keep all model weights within SRAM. And at that point, that basically takes away your memory bottleneck. And I think that is where you see the largest speed difference come from. I hope that answered this question more or less.
Yeah, I just was curious if the models that you're hosting are full precision models or are they quantized models? And for example, if a lot of the speed up comes from, for example, caching of tokens and things like that.
Yeah, very good question. Don't have an answer to everything there. But in general, we do run standardized models, which are just ONNX files that we get, for example, from Meta. And we just compile that with our compiler and put it onto our hardware. So basically, that is the flow. We, of course, probably, in certain cases, also make use of quantization, as everyone is doing. But I cannot answer specifically for models here, because I just don't know.
I think this is very much overlapping with the previous question, but do you utilize something like prompt caching that Anthropic has on some of their models to speed up generation, or?
So at the moment, prompt caching is basically to get your prompt into the model weights. Is that what we're talking about? So feeding your input tokens, or am I completely off?
I think so, yes.
Yeah, so I think because we are streaming architecture, we actually stream through our tokens in a certain way. So we go token per token. And because our pipeline goes that fast, we actually see that speed up. There's indeed possibilities to batch in your prompt because that is unrelated from the tokens generated at that point. And these techniques we can use, but it's independent from the hardware. At that point, it is a software optimization to your stack. So yes. Cool. I think we need to wait for the microphone to be sure. No problem.
How much speed up would you consider to be possible in the upcoming 2 years?
So in the upcoming 2 years, I think we still are going to make a lot of speed up, basically. So currently our 40 nano architecture still. So that's 40 nanometers for our chip. It's not our last chip we will build. But the nice thing is that the way that the architecture is architected is that it's not static at this point. So we basically have a lot of like math people and compiler engineers that are still optimizing our compiler, which basically still gives us improvements every week that we do development on top of it. So we're not going to sit still. We're going to keep improving basically on speed up, and we definitely didn't reach the finish line yet.
Estimate?
Estimate is always hard here, right? And then you probably have to ask a few of our modelers. But I think definitely with newer generations coming out, we can easily still look at like multiply improvements. And you're giving me a 2-year time frame, so that makes it a little bit easier, right?
Yeah. Are the main gains going to be in compiler side or more on the hardware side in this case as well?
So it's going to be both. It's going to be a combination of both. I expect it actually is a third component, which is system side. You also have to kind of like architecture your system correctly. I think in computers in general, we got some problems. One of them is actually getting your data into your compute to actually start your compute. For example, if you take a GPU, you still need to move all that input data into your GPU. I think there's possibilities where we can create speedups. I think there's possibilities in like just general having better compute available, and I think there's possibilities in just modeling these mathematical problems that we have better in the compiler, so that we actually can improve there. So I expect it's going to be across the board.
Perfect, thank you. Well, one last question, but still, the very last.
Thank you. I understand that there are a lot of variables at play, but based on your experience, if you have to think about the next decade, what do you think that's going to happen in terms of trend of the cost of prompting and using AI in general?
It's an interesting question. It's a question I don't think about a lot. So this is going to be a complete personal opinion at this point, but
of course.
So currently we generate quite a lot of data, right, which makes it quite powerful. So I think things that we saw in this room already, how can we reduce the amount of output we generate? So we first of all get better latencies on this output, and we second of all need to utilize our hardware less, because basically the more that hardware is crunching, the more power it is also consuming. And that is never going to be for free, even if we can completely minimize the cost of like the hardware out of it. So in general, I think it depends on like the content, but every token that needs to be calculated should need to be calculated. We should not over-calculate because we have the power available eventually. So I think models that can make sure that the compute that they are doing is actually useful are going to be more interesting in the future.
Thank you.
Cool.
All right, thank you so much, Max.
No problem.